Welcome to my video where I'm going to show you the solutions to the matrices multiplication exam questions. If you haven't already tried these questions and want to, click on the link in the video's description and you can try them there. So for this first question, we're multiplying a scalar by a matrix. So we do 6 times negative 2, which gets you negative 12, and then 6 times 5, which gets you 30. We do the same approach for question 2. Negative 4 times 8 is negative 32, and negative 4 times negative 1 is positive 4. For questions 3 and 4, we're also multiplying a scalar by a matrix. So we'll do 3 times all of the numbers in this matrix. So 3 times 5, which is 15, 3 times 1, which is 3, 3 times 2, which is 6, and 3 times 0, which is 0. Again, it's similar with the next one. Negative 4 times 6 is negative 24. Negative 4 times negative 2 is positive 8. Negative 4 times negative 2 is positive 8 again. And negative 4 times positive 4 is negative 16. Now we're multiplying a 2 by 2 matrix by a 2 by 1 matrix. So we'll start by doing 4, 0 and multiply this with 1, 5. 4 times 1 is 4 and 0 times 5 is 0, so that's just 4. And then we do 2, 1 and we'll pair this up with 1, 5. So 2 times 1 is 2, 1 times 5 is 5, and add 2 and 5 together and you get 7. A similar approach with this next one. So we have negative 3, 1 with 2 negative 1. Negative 3 times 2 is negative 6. 1 times negative 1 is negative 1, and if you add negative 6 and negative 1 you get negative 7. We then do 6 negative 2 and pair this up with 2 negative 1. So 6 times 2 is 12. Negative 2 times negative 1 is a positive 2, and 12 add 2 is 14. We're now going to multiply two 2 by 2 matrices. So we do 2, 3 with 1, 4. 2 times 1 is 2, and 4 times 3 is 12, and then you add 2 and 12, you get 14. 2, 3 with 0, 2. You do 2 times 0, which is 0, and 3 times 2, which is 6. 0 add 6 is 6. Then 0, 5 with 1, 4. 0 times 1 is 0. 5 times 4 is 20, and 0 add 20 is 20. And finally 0, 5 with 0, 2. 0 times 0 is 0, and 5 times 2 is 10. 0 add 10 is 10. In this next one we start with 2, negative 4, and pair that up with 1, 4. 2 times 1 is 2. Negative 4 times 4 is negative 16, so 2 takes 16 is negative 14. We then do 2 negative 4 with negative 1, negative 3. 2 times negative 1 is negative 2. Negative 4 times negative 3 is a positive 12, so negative 2 add 12 is 10. We then do 0, 3 with 1, 4. 0 times 1 is 0, and 3 times 4 is 12. 0 add 12 is 12. And finally 0, 3 with negative 1, negative 3. 0 times negative 1 is 0, and 3 times negative 3 is negative 9. 0 take 9 is negative 9. For this question we need to multiply 3 matrices together. To do this we'll look at the first 2 matrices and ignore the last one for the moment. So we'll do 3, 5 with 1, 2. 3 times 1 is 3 and 5 times 2 is 10. 3 add 10 is 13. We then do 3, 5 with negative 1, 2. 3 times negative 1 is negative 3. 5 times 2 is 10, and negative 3 add 10 is 7. Then 4, 0 with 1, 2. 4 times 1 is 4. 0 times 2 is 0, and 4 add 0 is 4. And finally 4, 0 with negative 1, 2. 4 times negative 1 is negative 4, and 0 times 2 is 0, so negative 4 add 0 is negative 4. So the first 2 matrices multiplied together gives us this matrix, 13, 7, 4, negative 4. So we can multiply this one by the last column matrix here, 3, negative 2. So we do 13, 7 with 3, negative 2. 13 times 3 is 39, and 7 times negative 2 is negative 14. So 39 take 14 gives you 25. And then we do 4, negative 4 with 3, negative 2. 4 times 3 is 12, and negative 4 times negative 2 is positive 8. So 12 add 8 gives you 20. For this question, I'd first of all multiply the scalar 5 by the first matrix. So this will give us a 2 by 2 matrix. 5 times negative 2 is negative 10, 5 times 4 is 20, 5 times negative 3 is negative 15, and 5 times 0 is 0. We can then multiply this result by the final 2 by 1 matrix 1, 5. So we'll do negative 10, 20 with 1, 5. Negative 10 times 1 is negative 10, and 20 times 5 is 100. Negative 10 add 100 is 90. We then do negative 15, 0 with 1, 5. Negative 15 times 1 is negative 15, and 0 times 5 is 0, so negative 15 add 0 is negative 15. We can start this question by multiplying the scalar 3 by the first matrix. So this will give us a 2 by 2 matrix. 3 times 0 is 0, 3 times 3 is 9, 3 times negative 1, negative 3, and 3 times 0 is 0. We can then multiply this result by the final 2 by 2 matrix. This will give us a 2 by 2 matrix. So we'll do 0, 9 with 6, negative 2, 0 times 6 is 0, and 9 times negative 2 is negative 18, so 0 take 18 is negative 18. Then 0, 9 with 1, negative 1, 0 times 1 is 0, 9 times negative 1 is negative 9, so 0 take 9 is negative 9. Negative 3, 0 with 6, negative 2, negative 3 times 6 is negative 18, and 0 times negative 2 is 0, so negative 18 add 0 is negative 18. Finally, we have negative 3, 0 with 1, negative 1, negative 3 times 1 is negative 3, and 0 times negative 1 is 0, so negative 3 add 0 is negative 3. For part A of this question, we just need to do matrix A times matrix B. So 5, 2 with negative 1, 0, 5 times negative 1 is negative 5, and 2 times 0 is 0, so negative 5 add 0 is negative 5. Then 3, negative 3 with negative 1, 0, 3 times negative 1 is negative 3, and negative 3 times 0 is 0, so negative 3 add 0 is negative 3. For part B of this question, we need to do 2AC. To do this, I would do 2A first, so we multiply the matrix A by 2. So instead of 5, 2, 3, negative 3, it's going to be 10, 4, 6, negative 6, and then we multiply this by C. We know this will give us a 2 by 2 matrix. So we'll start with 10, 4, and 0, 3. 10 times 0 is 0, 4 times 3 is 12, and 0 add 12 is 12. We'll do 10, 4 with 1, 2. 10 times 1 is 10, 4 times 2 is 8, and 10 add 8 is 18. Then 6, negative 6 with 0, 3. 6 times 0 is 0, negative 6 times 3 is negative 18, so 0 take 18 is negative 18. And finally 6, negative 6 with 1, 2. 6 times 1 is 6, negative 6 times 2 is negative 12, and then 6 take 12 is negative 6. For part C of this question, we need to do C squared, which just means C times C. So we'll do matrix C times matrix C again. This will give us a 2 by 2 matrix. So we'll do 0, 1 with 0, 3, 0 times 0 is 0, and 1 times 3 is 3, 0 add 3 is 3. Then 0, 1 with 1, 2, 0 times 1 is 0, 1 times 2 is 2, and 0 add 2 is 2. We then do 3, 2 with 0, 3, 3 times 0 is 0, 2 times 3 is 6, 0 add 6 is 6. And finally 3, 2 with 1, 2, 3 times 1 is 3, 2 times 2 is 4, and 3 add 4 is 7. In this question, we need to find AC and CA. So let's start with AC, which is matrix A multiplied by matrix C, which gives you a 2 by 2 matrix. So we'll do 5, 2 with 0, 3, 5 times 0 is 0, 2 times 3 is 6, and 0 add 6 is 6. Then 5, 2 with 1, 2, 5 times 1 is 5, 2 times 2 is 4, and 5 add 4 is 9. Then 3, negative 3 with 0, 3, 3 times 0 is 0, and negative 3 times 3 is negative 9, so 0 take 9 is negative 9. And then 3, negative 3 with 1, 2, 3 times 1 is 3, negative 3 times 2 is negative 6, so 3 take 6 is negative 3. We'll now look at CA, which is matrix C multiplied by matrix A, which again gives you a 2 by 2 matrix. So we'll do 0, 1 with 5, 3, 0 times 5 is 0, and 1 times 3 is 3. Then we do 0, 1 with 2, negative 3. 0 times 2 is 0, 1 times negative 3 is negative 3, and 0 take 3 is negative 3. Next we do 3, 2 with 5, 3. So 3 times 5 is 15, and 2 times 3 is 6, 15 add 6 is 21. And finally 3, 2 with 2, negative 3. 3 times 2 is 6, and 2 times negative 3 is negative 6, so 6 take 6 is 0. You can see from this that AC and CA don't give you the same result, so AC is unequal to CA. We can say therefore, matrix multiplication is not commutative. In this question we're going to multiply some 2 by 2 matrices. We have square root 3 1 times 2 0, square root 3 times 2 is 2 root 3, and 1 times 0 is 0, so it's 2 root 3 add 0, which gives you 2 root 3. Then we do square root 3 1 times square root 3 1. Square root 3 times square root 3 is 3, and 1 times 1 is 1, so we have 3 add 1, which is 4. We then do 1 root 2 times 2 0, so we have 1 times 2, which is 2, and root 2 times 0 is 0, so it's 2 add 0, which is 2. And finally 1 root 2 multiplied with root 3 1, so 1 times root 3 is root 3, and root 2 times 1 is root 2, so it's root 3 add root 2, which we would just write as root 3 add root 2. In this question we're just multiplying 2 by 2 matrices, but we must make sure we fully simplify our answer. So we're going to do A4 with 2A, A times 2 is 2A, and 4 times A is 4A, so we have 2A add 4A, which gets you 6A. We then do A4 with 4A squared and negative A cubed. A times 4A squared is 4A cubed, and 4 times negative A cubed is negative 4A cubed. So we have 4A cubed, take away 4A cubed, which gives you 0. We then do A squared A with 2A. A squared times 2 is 2A squared, and A times A is A squared, so we have 2A squared, add another A squared, which gets you 3A squared. And finally, A squared A with 4A squared, negative A cubed. A squared times 4A squared is 4A to the 4, and A times negative A cubed is negative A to the 4. So we have 4A to the 4, take away 1A to the 4, which is 3A to the 4. We can start this question by multiplying the left-hand side. We'll begin with A times the first matrix, so A times 4 is 4A, A times 1 is just A times 0 is 0, and A times negative 2 is negative 2A. We then multiply this by the 2 by 1 matrix B negative 3, so we'll do 4AA with B negative 3. 4A times B is 4AB, and A times negative 3 is negative 3A, so it's 4AB take 3A. We then do 0 negative 2A with B negative 3, 0 times B is 0, and negative 2A times negative 3 is a positive 6A. We've now worked out one matrix to represent the left-hand side. The right-hand side up here is negative 9, 9. So if we equate these, we can form two equations. 4AB take away 3A must be equal to negative 9. And if we look at the bottom part, 6A must be equal to positive 9. The right-hand one of these is quite easy to solve. If you divide both sides by 6, you get A equals 1.5. We can now substitute A equals 1.5 into the other equation, so we'd have 4 lots of A, which we know is 1.5, and then B, and then take away 3 lots of A, but we know A is 1.5, and this equals negative 9. 4 times 1.5 is 6, so the first term is just 6B, and 3 times 1.5 is 4.5, so we're taking 4.5, and this equals negative 9. If we add 4.5 to both sides, on the left we get 6B, and on the right we get negative 4.5. At this point, it might be sensible to times both sides of the equation by 2 to remove the decimal. So 6b times 2 is 12b, and negative 4.5 times 2 is negative 9. And finally, you can divide both sides by 12, and you'll get b equals negative 9 over 12, which of course simplifies to negative 3 over 4. So we have the answers A is 1.5, and B is negative 3 over 4. To begin this question, we'll multiply the matrices on the left-hand side. So begin with 0c and d3. 0 times d is 0, and c times 3 is 3c. 0 add 3c is 3c. We then have dd with d3. D times d is d squared, and d times 3 is 3d, so it's d squared plus 3d. This is the matrix for the left-hand side. Up here we can see the right-hand side is equal to negative 12, 10. So we can form two equations. If we look at the tops, 3c equals negative 12, and if we look at the bottoms, d squared plus 3d equals 10. The left of these equations is quite easy to solve. Divide by 3 on both sides, and you get c equals negative 4. For the right-hand one, if we take away 10 from both sides, we get d squared plus 3d, take away 10, equals 0. This is a quadratic that we can factorize. It's d plus 5, d take 2, and this gives you two solutions for d. D is negative 5, and d is positive 2. In this question, we're told that AB equals KC squared. So we'll start by working out AB, which is matrix A multiplied by matrix B. So this will give us a 2 by 2 matrix. We'll do 3, 4 with 1, 3. 3 times 1 is 3. 4 times 3 is 12. 3 add 12 is 15. We then do 3, 4 with x1. 3 times x is 3x, and 4 times 1 is 4, and 3x add 4 is just 3x add 4. 3, 1 with 1, 3. 3 times 1 is 3. 1 times 3 is also 3. 3 add 3 is 6. And then 3, 1 with x1. 3 times x is 3x. 1 times 1 is 1, so we add 3x add 1. We also need to make the right-hand side, which is kc squared. To do this, I'm going to do k times c first, and then times that by c again. The matrix C is just 4, 2, 2, 0, so if we multiply that by k, it will be 4k, 2k, 2k, and 0. So that's k times c, and we need to times that by c again. So if we do 4k, 2k, multiply 4, 2, 4k times 4 is 16k, and 2k times 2 is 4k, 16k add 4k is 20k. 4k, 2k with 2, 0. 4k times 2 is 8k, and 2k times 0 is 0, so it's 8k add 0, which is just 8k. Then 2k, 0 with 4, 2. 2k times 4 is 8k, and 0 times 2 is 0, so 8k add 0 is 8k. And finally, 2k, 0 with 2, 0. 2k times 2 is 4k, and 0 times 0 is 0, so it's 4k add 0, which is 4k. Now we're told in the question that AB equals KC squared, so the two matrices we've just worked out must be equal. So if we look at these two in particular, if we equate the top left-hand elements, we can see that 15 matches with 20k, so 15 must be equal to 20k. If you divide both sides of this by 20, you get k equals 15 over 20, which if you divide through by 5, gives you k equals 3/4. So we found the value for k. Now there are a number of ways of finding out x also, but I'm going to use the top right elements, so 3x plus 4 must be equal to 8k. We know what k is though, k is 3/4. So instead of 8k, we can do 8 times 3/4, which is 6. If we now take 4 from both sides, 3x equals 2, and then divide both sides by 3, x will equal 2/3. And for the final question, we'll multiply the left-hand side first. So we'll do 2b with a1, 2 times a is 2a, and b times 1 is b, so it's 2a plus b. And then a, 3b with a1, a times a is a squared, and 3b times 1 is 3b, so it's a squared plus 3b. Now this is the left-hand side. The right-hand side is equal to 819. If we equate these, the top gives us 2a plus b equals 8, and the bottoms give us a squared plus 3b equals 19. So we have two equations here with two unknowns. We can solve these simultaneous equations. I'm going to take the second equation and rearrange it so b is the subject. B would equal 8 minus 2a. I'll then rewrite the first equation but substitute b for 8 minus 2a. So it's a squared plus 3b, but we know that b is 8 minus 2a, so we'll put that inside the bracket here, and this equals 19. We have a squared If we expand the bracket, we get plus 24 take 6a, and this equals 19. And then if we take 19 from both sides to rearrange, we get a quadratic, a squared minus 6a plus 5 equals 0. This quadratic can factorize. We'd have a take 5, a take 1 equals 0, which gives you two solutions for a is positive 5 and positive 1. We can now get corresponding values for b. If we go back to our rearranged version here, b is 8 take 2a, so for the first one b is 8 take 2 lots of 5, 2 lots of 5 is 10, so 8 take 10 is negative 2, and for the second one b equals 8 take away 2 lots of 1, 2 lots of 1 is 2, so 8 take 2 gives you 6. Thank you for watching this video, I hope you found it useful. Check out what I think you should watch next and also subscribe so you don't miss out on future videos.